Okay, the last type of probability questions that I want to go over are binomial probabilities. So the way to check if something is binomial is using bins. There needs to be a clear-cut success or failure. Each trial needs to be independent. There has to be a set number of trials, and then you have to have a probability of success. If you can see that something's binomial, it's really nice because then you have a nice formula you can follow, and then we can do binomial PDF and CDF in our calculators. Make sure though that on the AP test you write the formulas out, not what you're typing in your calculator. Geometric is different. Geometric is when there's no set number of trials. You're just going to keep going until you get a first success. Otherwise it looks like binomial, but there's just no set number of trials. Okay, so we're going to do a binomial example. Okay, suppose the probability of getting a bullseye playing darts is 0.37. We're going to throw the darts. We're going to do 25 throws, and we're going to count the number of bullseyes. Each throw is independent. So a success is getting a bullseye, a fail is not. Each throw is independent. We have a set number, 25, and we have a probability of success, 0.37. So it's binomial. So the first question is asking how many bullseyes would we expect to get? Well, expect would be like expected value, which is also a mean, an average. Now this is binomial. So if we go back, way back to the very first page, remember these formulas were here, I said binomial. This is the mean, n times p. So, okay, if I want to find the mean, we're going to do n times p. N is the number of trials, 25. P is the probability of success, which we were told was 0.37. Multiply those together, and we would expect to get 9.25 bullseyes in 25 throws. Now, even though you can't technically get 9.25 bullseyes, you leave it as 9.25. Don't round or anything. Leave it exactly like that. Okay, now we're going to do a probability problem. What's the probability that we get in the range from 5 to 9 bullseyes, inclusive? So that means from 5 to 9. Okay, so if I write it out, 5 to 9 would look like that. Okay, so out of 25 attempts, we want to get 5 bullseyes. This is also known as 25, choose 5. Then we do the probability of success, 0.37, to the bottom number, which is a 5. And then we want the probability of failing, 1 minus 0.37. Do it here, 1 minus 0.37 is 0.63. So this is the probability of failing. Now if we succeed 5 times, then we would fail 20 times. You do the top number minus the bottom number. Now that's just specifically for 5. We're told to go from 5 to 9. So out of the 25 times, I could succeed 6 times. Probability of succeeding to the 6th. Probability of failing the other 25 minus 6 times, the other 19 times. Okay, now I still need to take care of 7 and 8 and 9, but I don't need to write all that out. The minimum amount of work to write out is the first one plus the second one plus dot 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 plus the last one. The last one would be 25, choose 9, 9 is the last one, 0.37 to the 9th, 0.63 to the 25 minus 9. so to the 16th. Now, you don't need to type all that in your calculator, but this is all the work you're supposed to show, okay? Now we're going to type the stuff in the calculator. I'm not going to write out what I type in my calculator because the AP people hate that. They hate calculator speak. So this is what you write out. Now we're going to go to the calculator. And I need to get a new page. Okay, so we're going to go menu, probability, distributions. And since it's a range of values, we want binomial CDF, not normal CDF. You got to go down. So here's the binomial PDF and binomial CDF. PDF would be if you just have one, like exactly, like if I wanted exactly 5 bullseyes. CDF is when we have a range from like 5 to 9. So I'm going to click on that one. The number of trials was 25. The probability of success was 0.37. The lower bound was 5 and the upper bound was 9. Remember, we were going 5 to 9. Hit OK. There you go. 0.528. So all of this equals 0.528. Okay. What's the probability that we get more than 10 bullseyes? Okay, so the probability that X is more than 10. All right, well, let's start with 10. 25, choose 10. Probability of success, 0.37 to the 10th. Probability of failing, 0.63 to the 25 minus 10. Oh, I already made a mistake. What did I do? I'm glad I caught this. You see it? I need to be more than 10. So what should I start with? I should have started with 11. So then 0.37 to the 11th, and then 0.63 to the 25 minus 11. Okay, so yeah, I'm glad I made that mistake to show a point actually. Greater than 10, you got to start with 11. Okay, then the next one would be a 12. 25, choose 12. Probability of success to the 12th. Probability of failing to the 25 minus 12. So you got to do the first one, the second one, plus dot, 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 plus the last one. Well, what would the last one be? More than 10. Up to what? What's our maximum we can go up to? 25. 25 is the amount of darts we're throwing. So 0.37 to the 25th, 0.63 to the 0, because we'd have 25 minus 25. All right, so now you go back in your calculator, and we're going to do menu, probability, distributions, binomial, CDF. Number of trials was 25. Probability of success was 0.37. The lower bound this time is 11, and the upper bound is 25. Okay, we get 0.298. Okay, that's it for binomial. So now go ahead and get some work done, and I'll see you on the block days.